Greetings and salutations, everybody. This is Jacob. Okay, so how the heck do we go about unraveling this mystery, you ask? Seems confounding. Worry not, my friends. I'll walk you through this problem, and afterwards you'll know the ins and outs of it. You'll know it like the back of your hand. It'll take your understanding of algebra and math in general to the next level. Oh yes. You'll be able to mathematically formulate any word problem like nobody's business. So let's get right into it, shall we? Okay, so the problem states that we pour 1 liter of the alcohol solution from vial 1 to vial 2, then from vial 2 to vial 3. And we repeat this process, and it's asking us to find the initial alcohol concentration of vial 3. So before proceeding any further, let's first give some definitions. We'll call X the amount of pure alcohol that vial 3 had initially in milliliters, and L is the total volume of a liquid solution that vial 3 had initially, also in milliliters. Okay, so now let's start from the beginning. It says we transfer 1 liter of liquid from vial 1 to vial 2. So let's try to figure out the amount of pure alcohol that went into vial 2. How do we find that? Since the initial alcohol concentration of vial 1 is 5%, and it contains 50 mLs of pure alcohol per liter, correct? Since we have 50 milliliters per liter in vial 1, and we transfer 1 liter of solution to vial 2, and we are transferring 50 milliliters per liter times 1 liter equals 50 milliliters. So during the first transfer, we transferred 50 milliliters of pure alcohol to vial 2. Now we add that to the amount of pure alcohol that vial 2 had before the first transfer. So how do we find this? Since vial 2 had an initial alcohol concentration of 7%, that means it had 70 milliliters of pure alcohol per liter, correct? So the total amount of pure alcohol vial 2 had initially was 70 times 4 equals 280 milliliters. Since vial 2 had 4 liters of solution initially, correct? So 280 plus 50 equals 330 milliliters. That's the amount of pure alcohol vial 2 has after the first transfer, correct? So, moving on. We transfer 2 liters of solution to vial 3 from vial 2. So now we have to figure out how much pure alcohol went into vial 3 from this transfer. So this amount is 330 milliliters times the ratio of how much liquid we transfer to vial 3 to the total amount of liquid which vial 2 had after the first transfer, which is 2/5, correct? Since we added 1 liter to vial 2 from vial 1, and it already had 4 liters in it, hence it became 5 liters, and this equals to 132 milliliters. So we transferred 132 milliliters of pure alcohol from vial 2 to 3 during the first transfer. Okay, here's where the fun starts. How much pure alcohol did vial 3 have initially? It was X, right? Since that was what we defined it as, and after the first transfer, the amount of pure alcohol vial 3 had was X plus 132 milliliters, correct? Okay, so now what do we do? What do the initial conditions say? They say that after the first transfer and vial 3 occurred, the alcohol concentration in vial 3 went up by 4%. So how do we formulate this mathematically? So what was the alcohol concentration initially in vial 3? It was 100 times X over L, correct? How about afterward? It was 100 times X plus 132 over L plus 2000, since we added 2000 milliliters to vial 3 from 2. So since the difference of percentages is 4%, as it says in the initial conditions, now we have 100 times X plus 132 over L plus 2000 minus 100X over L equals 4. And let's simplify this a bit so we won't have to deal with large numbers. Let's divide both sides by 100. Now we get X plus 132 over L plus 2000 minus X over L equals 0.04. And that's our first equation. Now we need one more equation since we have 2 variables. Oh yes. Now let's look at the second transfer, since it says the whole process was repeated. So we transfer liquid from vial 1 to 2 again. So how much pure alcohol is transferred this time? Since the alcohol concentration in vial 1 hasn't changed, and we transfer the same amount of total liquid, then again we transfer 50 milliliters from 1 to 2. correct? So now here's where things get tricky. The alcohol concentration in vial 2 after the first transfer has changed. Since we had 330 milliliters in vial 2 after the first transfer, and we subtracted 132 milliliters from vial 2, they were left in vial 2, 330 minus 132, 198 milliliters were left in vial 2. Then we transferred 50 milliliters from 1 to 2 again, and the pure alcohol in vial 2 became 198 plus 50 equals 248 milliliters after the second transfer, correct? Moving on now to vial 3. We transfer again 2 liters of total liquid from vial 2 to 3. How much pure alcohol is transferred? This time it's 248 times 2 over 4. That ratio that we talked about earlier, which it has changed now in the second transfer. Since when we subtracted 2 liters of total solution from vial 2 and went down to 3 liters, then we added 1 liter from vial 1 again, and it became 4 liters, as much liquid as it had in the beginning. So the pure alcohol transferred this time is 124 milliliters. And this time the alcohol concentration in vial 3 went up by 0.5%. So we set up the second equation in the same manner like we did the first time. So the alcohol concentration in vial 3 after transfer 2 is 100 times X plus 256 over L plus 4,000. And the alcohol concentration before the transfer was the same as before. So now we have 100 times X plus 256 over L plus 4,000 minus 100 times X plus 132 over L plus 2,000 equals 0.5. And again, we divide both sides by 100 for convenience. We get X plus 256 over L plus 4,000 minus X plus 132 over L plus 2,000 equals 0.005. And this is our second equation. And we solve for X in the first equation. So how do we merge two fractions with different denominators? Do you remember from Algebra 1 or 2? You multiply the first numerator by the denominator of the second fraction, and you multiply the denominator of the first fraction with the second fraction's numerator, and you sum these two expressions, and you make the expansions, you gather like terms, and we end up with X equals minus 0.04 over 2,000 L squared plus 0.026 times L. And we plug that into our second equation, but we don't do that immediately. First, let's simplify the second equation a bit before plugging in the value for X. That way we don't have to keep carrying large expressions over and over again. That's a neat little tip I have for you, my friends, when dealing with large expressions. So after sufficient algebraic operations have been made, you plug in the X value, you make more simplifications, and you end up with a quadratic equation, 0.035 times L squared plus 42L minus 56,000 equals 0. And the solutions of this is 800 milliliters and minus 2,000 milliliters. And since we can't have a negative solution for our volume, hence our only solution is L equals 800 milliliters. And we plug in this value in our first equation, and we get X equals minus 0.04 over 2,000 times 800 squared plus 0.026 times 800. And we end up with 8 milliliters as the amount of pure alcohol in vial 3 initially. So the initial concentration of alcohol in vial 3 was 100 times 8 over 800, which is 1%. So let's just quickly verify that this is indeed the answer, my friends. So we plug these values in our first equation, and we get 8 plus 132 over 2,000 plus 800 minus 8 over 800 equals 140 over 2,800 minus 8 over 800, which is 0.05 minus 0.01, which is 0.04, which is indeed what we have in our first equation. So that's curtains, my friends. That's your answer. Oh yes, 1%. That's quite an intuitive answer, if you ask me. So that was a fun little algebra puzzle, wasn't it? You know, as interesting as this problem was, how I actually came about constructing this problem is even more interesting than the problem itself, my friends. Even though this isn't the hardest problem to actually solve, but constructing it was a different story entirely. It was a difficult birth, for sure. The baby didn't come out willingly. Trying to come up with initial conditions for this problem, I kept coming up with quadratic equations that couldn't be solved, or with solutions that didn't make any physical sense. Like I kept ending up with pure alcohol amounts that were bigger than the actual total volume of liquid, for example. I mean, this problem drove me nuts. At some point, I even tried to work backwards to assume the solutions and try to come up with the parameters, the percentage increases, for example. But I kept getting nonsensical answers. And finally, after 2 or 3 days of doing the calculations over and over again, after killing 2 or 3 small trees trying to fix this problem, it finally dawned on me what I was doing wrong. You're not going to believe it. You're not going to believe what I was doing wrong, my friends. It turned out that I was working with 2 different units. The x variable was in milliliters, but the L was in liters. So in my first equation, I had L plus 2 instead of L plus 2000, and the numerator was in milliliters. And it took me 3 days of doing the calculations over and over again to realize this. It was a huge brain fart that eluded me for 3 days. My friends, I considered throwing in the towel and posting an alternative problem, and I almost did. But I was gung-ho on making this thing work because I really do think this algebra problem will skyrocket your mathematical formulation skills. You know, my friends, I don't just pose problems at random. There's a reason I select the problems that I do. If I wanted to, I could just grab the first Math Olympiad question that I came across and just post it, or some problem from a book, from a textbook. So I'm glad I didn't quit, because now we have this marvelous problem to sink our teeth into. Oh, yes. I mean, we solve problems or we die trying. And this is not just a catchphrase, my friends. We're living it. The next puzzle will truly be a doozy. You're going to love it. So let me know in the comments if you like this puzzle, if you solved it another way, if you solved it upside down, for example. Shoot a puzzle in category suggestion my way. You know the drill, my dudes and dudettes. Smash those buttons like they owe you money, and I'll see you guys in the next video. Bye-bye.